Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into a gentle but profound question. Is reality just an illusion? Before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if these calm explorations truly bring you a sense of ease. And when you're ready, feel free to leave a comment sharing where in the world you're listening from and what time it is for you right now. It's always a joy to imagine all of us gathering from different corners of the planet, each in our own quiet moment. Now, you might dim the lights, maybe turn on a fan for a soft background hum and let your shoulders relax. If your mind wanders, that's perfectly fine. Let it drift. We'll still be here, quietly unfolding the story, slowly, gently, and without urgency. We begin with what feels most familiar. You're likely sitting or lying down, perhaps aware of the weight of your body, the steady rhythm of your breathing, the soft sounds around you. There may be a floor beneath your feet, a bed beneath your back, a ceiling above you. All of this feels solid, dependable, and unquestionably real. This everyday sense of reality is deeply comforting. It tells you where you are, how to move, and what to expect next. When you reach for a glass of water, your hand meets it. When you glance at a clock, the numbers advance one by one. Morning follows night, and night returns again. The world appears stable, continuous, and reliable. Yet this stability is not something you consciously construct. It arrives fully formed, like a finished painting that you never watched being made. Your brain assembles countless signals, light, sound, pressure, temperature, into a seamless experience. You do not notice the assembly process any more than you notice the individual frames of a film while watching a movie. You simply experience the story. It is worth pausing here, because this is where the question of illusion quietly enters. Not as a challenge, not as a threat, but as a gentle curiosity. If your experience of reality is assembled for you, rather than delivered raw and untouched, then what you perceive is already a kind of interpretation. Consider vision. Light reflects from objects, enters your eyes, and is transformed into electrical signals. Those signals travel along nerves and are reconstructed by your brain into colours, shapes, and depth. The redness of a rose, the blueness of the sky, the sharp edge of a shadow, none of these exist exactly as you experience them outside your mind. They are your brain's best and most useful translation of what is happening around you. This does not make them false. A translation can be accurate without being literal. A map is not the land, yet it can guide you across it. In much the same way, your everyday reality may be less like the land itself and more like a beautifully crafted map, optimized for navigation, survival, and comfort. Your brain evolved with a very practical mission. It did not evolve to reveal the deepest layers of existence. It evolved to keep you alive, to help you find food, avoid danger, recognize faces, and navigate social life. Anything beyond that, atoms, fields, probabilities, dimensions, was not required for survival on the savannah or in early villages. Because of this, your sense of reality is shaped by usefulness, not completeness. It emphasizes solid objects, smooth motion, and clear cause and effect. It hides anything too small, too fast, or too abstract to matter in daily life. You do not feel the constant motion of the planet beneath you, nor the vastness of space stretching overhead. You do not sense the microscopic activity within your own cells. All of that is quietly filtered away. A helpful image is that of a calm lake at dawn. On the surface, the water appears still, almost glassy. Reflections are clear and undisturbed, but beneath that surface currents move, temperatures vary, and countless tiny interactions unfold. The surface is not lying to you. It is simply showing you what is most relevant at that scale. In the same way, everyday reality may be the surface layer of something deeper, not a deception, but a simplification. A smooth interface over a more complex foundation. This idea becomes even more familiar when we think about tools we use every day. When you tap an icon on a phone screen, you are not interacting directly with circuits and electrical signals. You're touching a carefully designed interface. The icons are not the phone's true inner workings, yet they are real in their function and meaning. They allow you to communicate, learn, and connect. If you had never opened the phone to see its components, you might reasonably assume that the icons themselves were all there was. Only later would you discover that beneath the surface lies another layer entirely, one that operates by different rules and at a different scale. Everyday reality may be similar. What you experience is consistent, reliable, and meaningful, but it may not be the final layer. It may be an interface shaped by evolution and perception, presenting the world in a form that is easy to live inside. This thought does not require alarm or skepticism. It can be held gently, like a question resting on the edge of awareness. If what you see is a surface, then curiosity naturally arises about what lies beneath, not because the surface is wrong, but because depth invites wonder. As we rest with this idea, notice how it changes nothing about your immediate experience. The room is still quiet, your breathing remains steady. The world continues exactly as it was, and yet a small window has opened, an invitation to explore reality not as something that suddenly becomes uncertain, but as something that may be richer and deeper than it first appears. With that quiet curiosity in mind, we can let our thoughts drift forward, slowly and without effort, toward the moments when science itself began to notice that the comforting surface of reality might not tell the whole story. There was a time when reality felt simple in a reassuring way. For centuries, people imagined the universe as a vast but orderly machine. Objects moved when pushed. Time flowed the same way everywhere. Space was a quiet, invisible stage where events simply took place. This view fit everyday experience so well that it felt almost beyond question. If you rolled a stone across the ground, it slowed and stopped. If you threw it harder, it travelled farther. The rules seemed obvious, predictable, and universal. This picture of reality worked beautifully for building bridges, predicting eclipses, and navigating the seas. For a long while, it felt as though humanity had finally grasped how the universe truly worked. But slowly, almost politely, nature began to disagree. The first cracks appeared when scientists looked more closely at motion and gravity. Careful measurements revealed that space and time were not as rigid as they seemed. They were not separate, silent backgrounds. Instead, they behaved more like a flexible fabric, able to stretch and bend. A useful image is that of a thick rubber sheet. Place a heavy ball in the centre, and the sheet curves downward. Smaller objects nearby roll toward it, not because they are pulled by an invisible force, but because the surface itself has changed shape. In this picture, gravity is not something acting through space. It is something space itself is doing. This idea gently overturns everyday intuition. You do not feel space bending beneath your feet. You do not sense time stretching as you move. Yet careful observation shows that clocks tick slightly differently depending on motion and gravity. Time, it turns out, is not a single universal river. It flows at subtly different rates, depending on where and how you are moving. Even so, this new picture still felt smooth and continuous. Space and time might be flexible, but they were still orderly. Reality still felt like a coherent story, just written in a more elegant language. Then physics looked closer still into the realm of the very small, and here, the story changed more dramatically. At tiny scales, nature refused to behave like a machine. Particles didn't move along neat paths. Instead, they behaved more like possibilities than objects. They appeared, disappeared, and interacted in ways that could only be described using probabilities. Imagine trying to predict the exact path of a leaf drifting through still air. You can describe its general motion, but tiny currents make its precise position unpredictable. Now imagine that unpredictability is not due to ignorance or chaos, but is built into reality itself. That is the kind of uncertainty physics encountered. In this microscopic world, you can no longer say with certainty where something is and how fast it is moving at the same time. You can only speak in ranges, tendencies, and likelihoods. Reality becomes less like a solid sculpture and more like a shimmering cloud. This was deeply unsettling. It was not merely that the math was complicated. It was that the universe itself seemed to resist being pinned down. The more precisely scientists tried to measure certain properties, the more other properties slipped away. Yet again, this was not philosophy intruding into science. It was observation forcing science to adapt. What makes this moment especially important for our quiet exploration is that these discoveries did not replace everyday reality. They didn't make tables vanish or clocks stop working. Instead, they reveal that the familiar world sits on top of something far stranger. Think of walking across a frozen lake. From above, the surface looks solid and continuous. You can walk, sit, even build on it. But beneath the ice, water molecules vibrate, collide, and rearrange. The solidity you experience emerges from countless unseen motions. In much the same way, the stability of everyday reality appears to emerge from deeper processes that do not resemble solid objects at all. At their foundation, things are less like bricks and more like patterns of activity. This realization introduces a subtle but powerful shift. Reality is no longer defined by what feels obvious. Instead, it becomes layered. There is the layer we live in, touch, and trust. And beneath it, there are layers that only careful instruments and patient reasoning can reveal. Importantly, these deeper layers do not feel intuitive because intuition evolved for survival, not for truth at the smallest or largest scales. Your senses are tuned to the middle ground, where objects are neither microscopic nor cosmic, neither moving near light speed nor vibrating at extreme energies. This helps explain why modern physics often feels strange or even unsettling. It is not that reality became weird. It is that we finally noticed parts of it that were never meant to be directly felt. As these discoveries accumulated, a quiet question began to take shape. If space can bend, time can stretch, and matter can exist as probabilities rather than solid things, then what exactly is the reality we experience every day? Is it the full story, or is it a carefully smoothed surface over something more complex? This question does not demand immediate answers, it simply asks for patience. It invites us to loosen our grip on the idea that what feels obvious must be fundamental. In doing so, it opens the door to ideas that once seemed impossible, not because they are fantastical, but because they operate at depth far removed from everyday experience. With this in mind, it becomes easier to accept that reality might not be something we directly see, but something we interpret. A story told to us by our senses, shaped by evolution, and refined by habit. And like all stories, it may leave out details that only become visible when we step back and listen more carefully. Holding that thought gently, we can allow our attention to drift toward the idea that what we call reality might be less like a finished picture and more like a carefully designed interface, useful, reliable, and meaningful, yet not the deepest layer of what truly exists. As the discoveries of modern physics slowly settled in, They left behind a quiet but persistent unease. Space could bend, time could stretch, matter could behave like a cloud of possibilities, and yet none of this was visible in daily life. Chairs remained firm, floors stayed beneath our feet. The world still felt solid and dependable. This contrast invites a thoughtful question. If reality behaves one way at its deepest levels, but appears very different in everyday experience, then what exactly are we perceiving? One helpful way to think about this is through the idea of an interface. An interface is not the inner machinery of a system. It is a simplified layer designed to make interaction easier. When you look at a digital clock, you see glowing numbers, not the electrical pulses inside the device. When you swipe a screen, you move icons, not streams of code. The interface hides complexity, not to deceive you, but to help you function smoothly. Now imagine trying to live your daily life while constantly perceiving every microscopic detail of reality. Imagine feeling every vibration of every molecule beneath your feet, every fluctuation of energy in the air around you. The world would not feel meaningful or navigable. It would feel overwhelming. Your brain, shaped by millions of years of evolution, learned to present you with what matters most for survival. Solid objects, clear edges, predictable motion, familiar colours and sounds. These are not arbitrary choices, they are practical ones. In this sense, everyday reality may be less like a photograph and more like a dashboard. It shows you what you need to know in order to move, eat, rest, and connect with others. Everything else is quietly filtered out. This idea does not suggest that reality is fake. A dashboard is not fake because it hides the engine. It is simply selective. The information it provides is real, but it is organized for usefulness rather than completeness. Consider color. The world does not contain color in the way we experience it. There are no reds or blues floating through space. Instead, there are patterns of light interacting with matter. Your brain translates these interactions into color experiences because they help you distinguish ripe fruit from unripe, sky from ground, face from background. Color is not a lie. It is a translation. The same may be true of solidity. At deep levels, matter is mostly empty space, structured by invisible forces and patterns of motion, yet you experience objects as firm and impenetrable. That experience is not incorrect. It is simply a higher-level summary of countless interactions happening beneath awareness. From this perspective, reality is layered. There is the layer you experience directly, rich with sensation and meaning. Beneath it lie layers of description that grow more abstract and less intuitive as you descend. None of these layers cancel the others. They coexist, each useful in its own context. This layered view helps explain why scientific descriptions often feel cold or distant. They operate at levels far removed from everyday experience. When physicists speak of fields, probabilities, or dimensions, they are not denying the reality of tables and chairs. They are describing what tables and chairs are made of when viewed from a deeper level. A useful metaphor here is language. When you listen to a lullaby, you hear melody and emotion. You do not consciously analyze the sound waves, the vibrations of air, or the neural signals in your brain. Those processes are real, but they are not part of the experience of listening. The music exists at a higher level of meaning. In the same way, your lived reality exists at a level where meaning, intention, and continuity matter. Deeper layers describe how that level arises, not whether it is valid. This perspective gently reframes the idea of illusion. An illusion is often thought of as something false, something meant to trick. But many of the things we call illusions are simply emergent experiences. They arise from underlying processes without being explicitly present in those processes. A wave is not a single object, it is a pattern of motion across water. Yet the wave is real. You can see it, feel it, and be moved by it. Its reality does not depend on being a fundamental building block. It depends on being a stable, meaningful pattern. If everyday reality is similar, then calling it an illusion may be misleading. It is not an illusion in the sense of being fake. It is an illusion in the sense of being an appearance that emerges from deeper rules. This idea allows us to hold two truths at once. The world you experience is real and meaningful, and it may not be the deepest description of what exists. Importantly, this way of thinking does not diminish human experience. If anything, it enriches it. It suggests that your daily life unfolds on the surface of something vast and intricate, like ripples on an ocean whose depths stretch far beyond sight. As we sit with this thought, it becomes easier to approach bold ideas about reality without anxiety. Simulation, holography, hidden dimensions, and mathematical structures no longer sound like threats to common sense. They sound like attempts to describe the deeper layers beneath the interface we know so well. The comfort of everyday reality remains intact. You can still trust the ground beneath you and the rhythm of time as you experience it. But now, there is also room for quiet wonder, a sense that beneath the familiar surface, the universe may be organized in ways that are subtle, elegant, and far more interconnected than intuition alone would suggest. With that sense of layered reality gently in place, we can allow our thoughts to drift towards some of the bold frameworks that attempt to describe what might lie beneath the interface. Ideas that ask not whether reality is useful, but how deep its structure might truly go. Once the idea of reality as an interface is settled quietly in the mind, a particular question tends to arise on its own. If what we experience is already a carefully shaped presentation, then what might be doing the shaping? And could that presentation be deliberately constructed? This is where the simulation hypothesis enters, not with flashing lights or dramatic announcements, but almost shyly, as a possibility worth considering. The basic idea is simple to state. Our universe might be the result of an advanced process of computation. In this view, reality behaves less like a self-contained object and more like an ongoing calculation. Space, time, and matter would be the visible outputs of an underlying system, much like images and sounds appear on a screen when a program is running. To understand why this idea gained attention, it helps to look at something very familiar. Think about how far digital simulations have already come. Simple pixels became photographs. Flat images became moving worlds. Games once made of blocks and lines now contain landscapes, weather, and characters that respond to choices in real time. Virtual environments grow richer and more detailed every year. Now imagine extending that trend far into the future. Imagine a civilization that has learned to model not just surfaces but physics itself. Not just appearances, but the rules that govern interactions. In such a scenario, entire worlds could be simulated, complete with histories, environments, and even conscious beings who experience those worlds from the inside. At this point, an intriguing line of reasoning often appears. If it is possible to create simulated worlds, and if advanced civilizations tend to create many of them, then simulated realities could become far more numerous than the original physical one. In that case, a randomly chosen conscious observer would be more likely to find themselves inside a simulation than outside it. This reasoning does not rely on equations or complex calculations. It is closer to a thought experiment, similar to imagining a vast library. If one shelf contains a single book and another shelf contains millions of copies, it becomes statistically more likely that a randomly selected page comes from the larger collection. Still, it is important to pause here. This idea is not a scientific proof. It is not something that can currently be tested or measured. It belongs to philosophy, probability and speculation, rather than experimental physics. And that distinction matters. The simulation hypothesis does not claim that we are definitely living in a simulated world. It suggests only that such a scenario cannot be easily ruled out, given certain assumptions about technology and motivation. Whether those assumptions are reasonable remains an open question. When framed calmly, the idea loses much of its shock. It becomes less about undermining reality and more about asking what kind of foundation reality might rest upon. To make this more intuitive, consider a dream. While dreaming, you experience a world that feels complete. There is space, time, cause, and effect. Objects behave consistently enough that you rarely question them. Only upon waking do you realize that the dream world was generated by processes you were not aware of at the time. This does not mean the dream was meaningless. Emotions felt real. Experiences had impact. The fact that the dream was generated does not erase what it felt like to be inside it. The simulation idea invites a similar perspective. Even if reality were generated, it would still be the reality you live in. Your experiences, choices, and relationships would not suddenly lose their significance. This is one reason the idea resonates with some thinkers. It allows reality to be both structured and meaningful, even if its ultimate origin is unusual. At the same time, the simulation hypothesis raises deep questions. If reality is generated, is there a boundary? Is there a way to tell? Could there be imperfections, limits, or signs of an underlying system? Some people imagine glitches or hidden messages, but these ideas drift quickly into fiction. In serious discussions, most agree that a sufficiently advanced simulation would be indistinguishable from a base reality. Just as characters in a novel cannot read the author's notes, observers inside a simulation may have no access to the layer beneath. This is where humility becomes important. The simulation hypothesis does not offer predictions that can be tested in laboratories or observed with telescopes. It does not replace existing physical theories. Instead, it sits quietly alongside them, asking a different kind of question. Not, how does the universe work, but what kind of thing is the universe at its deepest level? This question feels unsettling only if we assume that reality must be simple, immediate, and transparent. But history suggests otherwise. Every time humanity has looked more closely, reality has revealed layers that were never suspected. From atoms to fields, from particles to probabilities, each step deeper has required letting go of comfortable intuitions. Seen this way, the simulation hypothesis is not a radical break. It is part of a long tradition of expanding our sense of what is possible, and yet there is wisdom in restraint. Without evidence, speculation must remain gentle. The value of this idea lies not in claiming answers, but in loosening assumptions. It encourages us to question whether the ultimate foundation of reality must resemble the surface we experience. As you rest with this thought, notice that nothing about your immediate surroundings changes. The room remains quiet. The world continues to behave as expected. The idea does not demand belief or disbelief. It simply offers a wider frame. With that frame in place, it becomes easier to explore other perspectives that do not rely on digital metaphors at all. Ideas suggesting that reality might be grounded not in computation, but in information, geometry, or mathematics itself. Those possibilities invite us to step even further beneath the interface, toward descriptions that feel less like stories and more like patterns quietly waiting to be recognized. As the idea of a simulated universe lingers in the mind, it often brings with it a subtle emotional response. For some, it is curiosity. For others, unease. A quiet question may surface, almost instinctively. If reality were generated, would anything still matter? This concern is understandable. Much of our sense of meaning is tied to the idea that the world is solid, original, and self-contained. The thought that reality might be constructed can feel like the ground shifting beneath familiar beliefs. Yet this reaction often comes from imagining simulation in the wrong way. When people hear the word simulation, they may picture something artificial, cheap, or hollow, like a flimsy stage set meant to fool an audience. But generation does not imply emptiness. A poem generated by a human mind is no less meaningful because it arose from neurons and electrical activity. A sunset does not lose its beauty because it can be explained through atmospheric physics. Meaning does not come from the ultimate origin of a thing. It comes from experience, relationship, and context. To see this more clearly, consider stories. A novel is entirely constructed. Every character, every event, every emotion on the page is the result of deliberate creation. And yet, readers laugh, grieve, and reflect, as if those characters were real companions. The meaning is not diminished by the fact that the story was written. In many cases, that knowledge deepens appreciation rather than erasing it. In the same way, even if reality were generated through some deeper process, the experiences within it would still be lived from the inside. Joy would still feel like joy. Loss would still feel like loss. Choice would still feel like choice. This brings us to the question of free will. The simulation idea is often misunderstood as implying that all actions are predetermined or controlled. But this is not necessarily the case. A system can be generated while still allowing open-ended behaviour within it. Weather patterns emerge from physical rules, yet no single gust of wind is scripted in advance. Complex systems often give rise to unpredictability, creativity, and novelty. If consciousness exists within such a system, then choice may be an emergent property rather than an illusion. Decisions could arise from internal processes, even if the underlying framework was established beforehand. Here again, the interface perspective is helpful. When you interact with a digital world, your choices are real within that world. They shape outcomes, relationships, and experiences. The existence of underlying code does not make your actions meaningless. It simply places them within a larger structure. Still, as calming as these reflections may be, it is important to recognize the quiet limits of the simulation idea. The simulation hypothesis does not explain how reality works. It does not replace physical theories. It does not tell us why the laws of nature have the particular form they do. Instead, it relocates the mystery one step deeper. If reality was simulated, we would still need to ask, what is the nature of the system doing the simulating? What laws govern it? Why does it exist at all? In this sense, simulation is not an answer so much as a reframing. It changes the language of the question without resolving its core. There is also the matter of evidence. Science advances by testing ideas against observation. It thrives on predictions that can be confirmed or ruled out. The simulation hypothesis, at least in its current form, does not offer such predictions. A perfectly detailed simulation would produce observations indistinguishable from a non-simulated universe. This does not make the idea worthless. It simply places it in a different category. It belongs to philosophical reflection rather than experimental confirmation. Recognizing this boundary is not a weakness. It is a sign of intellectual care. It reminds us that not every interesting idea needs to be believed, defended, or rejected. Some ideas exist to stretch imagination, to loosen assumptions, and to prepare the mind for other possibilities. In fact, one of the most valuable roles of the simulation idea may be psychological rather than scientific. By suggesting that reality could have a hidden structure beneath appearances, it encourages humility. It invites us to hold our understanding lightly, knowing that the surface story may not be the whole story. This humility opens the door to other perspectives that approach the same mystery from different angles. Some do not rely on computation or artificial worlds at all. Instead, they ask why abstract patterns, especially mathematical ones, seem so deeply woven into the fabric of existence. If simulation asks whether reality might be generated like a program, the next question asks something even quieter and more unsettling. Why does the universe behave as if it were written in the language of mathematics, regardless of who is observing it? This question shifts attention away from creators and machines and towards structure itself. It suggests that beneath appearances, beneath interfaces, and even beneath hypothetical simulations, there may be something more fundamental still. Something closer to pattern, relationship, and form. As you rest with this thought, there is no need to resolve it. Let it remain open, like a door left ajar. The idea of simulation has done its work if it has helped you loosen the assumption that reality must look the way it feels. With that loosened grip, it becomes possible to explore the next layer of the story, one where reality is not imagined as a digital construction, but as something shaped and perhaps even defined by mathematics itself. As the thought settles that mathematics seems to fit the universe almost too well, a deeper idea begins to emerge, one that feels both elegant and unsettling in its simplicity. What if mathematics is not just a language we use to describe reality? What if it is the substance of reality itself? This idea is known as the mathematical universe hypothesis. At its heart, it suggests that the universe is not made of stuff in the traditional sense. Instead, it is made of structure, relationships, patterns that exist consistently whether or not anyone observes them. To approach this idea gently, it helps to step away from images of chalkboards and symbols. Instead, think about patterns that exist independently of materials. A circle, for example, does not belong to ink, stone, or light. It belongs to a relationship, every point the same distance from a centre. You can draw it in sand, trace it in the air, or imagine it without drawing it at all. The circle is not the drawing. The drawing is only one expression of the idea. In this view, mathematics is not invented so much as discovered. Patterns exist first, and we gradually learn to recognize them. When scientists write equations that describe nature, they may not be imposing order on chaos. They may be uncovering an order that was always there. This perspective echoes ancient intuitions. Long before modern science, thinkers wondered whether numbers and relationships were more fundamental than matter. They noticed that harmony in music, symmetry in shapes, and cycles in nature all seemed to follow invisible rules. These rules felt timeless, as if they existed beyond human history. What modern physics adds is precision. When mathematical structures are explored deeply enough, they often predict phenomena no one was looking for. The predictions appear on paper first, as relationships between abstract quantities. Only later do experiments reveal that the universe behaves exactly as those relationships suggest. This creates a strange reversal. Instead of reality guiding mathematics, mathematics seems to guide our discovery of reality. To make this feel more intuitive, imagine a chessboard. The game of chess is defined entirely by rules and relationships. The board can be wooden, digital, or imagined. The pieces can be carved, drawn, or spoken of in words. But the game itself exists as a structure. Its possibilities are fixed, even if no one ever plays every possible match. If the universe is similar, then its laws may be expressions of an underlying structure that exists whether or not it is enacted. Our cosmos would be one realization of that structure, much like a single chess game, is one realization of the rules of chess. This idea grows even more expansive when taken to its logical conclusion. If one consistent mathematical structure can exist, then perhaps all consistent mathematical structures exist in some sense. Each would define its own possible universe, with its own internal rules and behaviors. At this point, the mind may feel stretched. That is natural. The idea does not ask to be accepted quickly. It asks only to be considered calmly. Critics of this view raise thoughtful concerns. Mathematics is vast, filled with countless structures that seem disconnected from physical reality. Why does our universe correspond to this particular set of patterns and not others? Why do we observe stable particles, flowing time, and expanding space rather than something entirely alien? One response is that only certain structures are capable of giving rise to observers. Patterns that allow complexity, persistence, and self-reference may be rare within the mathematical landscape. Our universe may not be typical. It may simply be one of the few places where awareness can arise and ask questions at all. This line of thought shifts the question from why does the universe exist to why does this kind of universe exist? It reframes existence as a matter of compatibility between structure and experience. Importantly, the mathematical universe hypothesis does not deny physical reality. Tables, stars, and bodies still exist as experiences within the structure. The hypothesis simply suggests that their ultimate nature is relational rather than material. This can feel abstract, but it carries a quiet beauty. It suggests that reality is not held together by force alone, but by coherence, by patterns that fit together so precisely that they can sustain worlds. There is also a humbling implication. If reality is a structure rather than a substance, then it does not revolve around observers. It exists because it is internally consistent, not because it is seen. Observation becomes participation rather than creation. At the same time, this view does not diminish human experience. Meaning does not vanish simply because it arises within a structure. Music does not lose its emotional power because it follows mathematical relationships. Love does not lose its depth because it can be studied through patterns of behavior and connection. If anything, meaning becomes more remarkable. It becomes something that emerges naturally when structure becomes rich enough to reflect on itself. As we rest with this idea, it is worth noticing how it differs from simulation. Simulation imagines a world generated by something else. The mathematical universe suggests a world that exists by virtue of its own internal order. No computer required, no external builder. Just consistency unfolding into experience. This distinction matters. It allows us to explore the depth of reality without imagining hidden controllers or unseen programmers. It shifts attention away from who might be running the universe and toward what kind of structure the universe might be. Still, even this idea may not be the final layer. Mathematics can describe structure, but it does not yet explain why certain structures feel real to us, while others remain forever abstract. It points toward a deeper question about selection, possibility, and perspective. With that gentle uncertainty, the mathematical universe hypothesis completes its role. It invites us to see reality not as a collection of objects, but as a woven fabric of relationships, quietly precise, deeply ordered, and vast beyond intuition. Holding that image softly, we can allow our thoughts to drift toward a broader view, one that asks what happens when we consider not just one structure, but many possible ones existing side by side. As the thought settles that mathematics seems to fit the universe almost too well, a deeper idea begins to emerge, one that feels both elegant and unsettling in its simplicity. What if mathematics is not just a language we use to describe reality? What if it is the substance of reality itself? This idea is known as the mathematical universe hypothesis. At its heart, it suggests that the universe is not made of stuff in the traditional sense. Instead, it is made of structure, relationships, patterns that exist consistently, whether or not anyone observes them. To approach this idea gently, it helps to step away from images of chalkboards and symbols. Instead, think about patterns that exist independently of materials. A circle, for example, does not belong to ink, stone, or light. It belongs to a relationship, every point the same distance from a centre. You can draw it in sand, trace it in the air, or imagine it without drawing it at all. The circle is not the drawing. The drawing is only one expression of the idea. In this view, mathematics is not invented so much as discovered. Patterns exist first, and we gradually learn to recognise them. When scientists write equations that describe nature, they may not be imposing order on chaos. They may be uncovering an order that was always there. This perspective echoes ancient intuitions. Long before modern science, thinkers wondered whether numbers and relationships were more fundamental than matter. They noticed that harmony in music, symmetry in shapes, and cycles in nature all seemed to follow invisible rules. These rules felt timeless, as if they existed beyond human history. What modern physics adds is precision. When mathematical structures are explored deeply enough, they often predict phenomena no one was looking for. The predictions appear on paper first, as relationships between abstract quantities. Only later do experiments reveal that the universe behaves exactly as those relationships suggest. This creates a strange reversal. Instead of reality guiding mathematics, mathematics seems to guide our discovery of reality. To make this feel more intuitive, imagine a chessboard. The game of chess is defined entirely by rules and relationships. The board can be wooden, digital, or imagined. The pieces can be carved, drawn, or spoken of in words, but the game itself exists as a structure. Its possibilities are fixed, even if no one ever plays every possible match. If the universe is similar, then its laws may be expressions of an underlying structure that exists whether or not it is enacted. Our cosmos would be one realization of that structure, much like a single chess game is one realization of the rules of chess. This idea grows even more expansive when taken to its logical conclusion. If one consistent mathematical structure can exist, then perhaps all consistent mathematical structures exist in some sense. Each would define its own possible universe, with its own internal rules and behaviours. At this point, the mind may feel stretched. That is natural. The idea does not ask to be accepted quickly. It asks only to be considered calmly. Critics of this view raise thoughtful concerns. Mathematics is vast, filled with countless structures that seem disconnected from physical reality. Why does our universe correspond to this particular set of patterns and not others? Why do we observe stable particles, flowing time, and expanding space rather than something entirely alien? One response is that only certain structures are capable of giving rise to observers. Patterns that allow complexity, persistence, and self-reference may be rare within the mathematical landscape. Our universe may not be typical. It may simply be one of the few places where awareness can arise and ask questions at all. This line of thought shifts the question from why does the universe exist to why does this kind of universe exist? It reframes existence as a matter of compatibility between structure and experience. Importantly, the mathematical universe hypothesis does not deny physical reality. Tables, stars, and bodies still exist as experiences within the structure. The hypothesis simply suggests that their ultimate nature is relational rather than material. This can feel abstract, but it carries a quiet beauty. It suggests that reality is not held together by force alone, but by coherence, by patterns that fit together so precisely that they can sustain worlds. There is also a humbling implication. If reality is a structure rather than a substance, then it does not revolve around observers. It exists because it is internally consistent, not because it is seen. Observation becomes participation rather than creation. At the same time, this view does not diminish human experience. Meaning does not vanish simply because it arises within a structure. Music does not lose its emotional power because it follows mathematical relationships. Love does not lose its depth because it can be studied through patterns of behavior and connection. If anything, meaning becomes more remarkable. It becomes something that emerges naturally when structure becomes rich enough to reflect on itself. As we rest with this idea, it is worth noticing how it differs from simulation. Simulation imagines a world generated by something else. The mathematical universe suggests a world that exists by virtue of its own internal order. No computer required, no external builder. Just consistency unfolding into experience. This distinction matters. It allows us to explore the depth of reality without imagining hidden controllers or unseen programmers. It shifts attention away from who might be running the universe and toward what kind of structure the universe might be. Still, even this idea may not be the final layer. Mathematics can describe structure, but it does not yet explain why certain structures feel real to us, while others remain forever abstract. It points toward a deeper question about selection, possibility, and perspective. With that gentle uncertainty, the mathematical universe hypothesis completes its role. It invites us to see reality not as a collection of objects, but as a woven fabric of relationships, quietly precise, deeply ordered, and vast beyond intuition. Holding that image softly, we can allow our thoughts to drift toward a broader view, one that asks what happens when we consider not just one structure, but many possible ones existing side by side. As thoughts of mathematical structure slowly fade into the background, another doorway opens, one discovered not through abstract reasoning alone, but through some of the most mysterious objects in the universe. These objects are dark, quiet, and distant, and yet they have taught us something surprising about the nature of reality itself. These objects are black holes. At first glance, black holes seem like the ultimate destroyers. They form when massive stars collapse under their own weight, compressing matter into an incredibly dense region. From the outside, they appear simple. They have mass, spin, and a boundary beyond which nothing can return. That boundary is often imagined as a one-way surface, a silent edge separating the known from the unknowable. For a long time, scientists believed that anything falling into a black hole was lost forever. Not just objects, but information itself. The detailed description of what those objects were made of and how they were arranged. This idea felt natural. After all, if nothing can escape, how could any information return? But slowly, a problem emerged. In physics, information is precious. It represents the complete description of a system. And according to the rules that govern the microscopic world, information is not supposed to disappear. It can be transformed, scrambled, or hidden, but not destroyed outright. This created a tension. Black holes seemed to erase information, while the deeper laws of nature insisted that information must be preserved. Something had to give. The resolution to this puzzle led to a remarkable realization. The information about everything that falls into a black hole does not vanish. Instead, it is somehow stored on the surface of that invisible boundary, the thin shell marking the edge of no return. This idea is difficult to picture at first. We're used to thinking that information fills volume. A book stores information throughout its pages. A room contains objects throughout its space. but black holes suggested something radically different. The amount of information associated with a black hole depends not on how much space it encloses, but on the area of its surface. To make this feel more intuitive, imagine a balloon. As you inflate it, the volume inside grows quickly, but the surface area grows more slowly. Now imagine that all the details about what is inside the balloon were somehow written only on its outer skin. No matter how much volume you add, the information remains tied to the surface. This runs against everyday intuition, and that is precisely why it is so important. If nature truly behaves this way in extreme conditions, then our assumptions about space may need revision. Perhaps volume is not as fundamental as it feels. Perhaps surfaces matter more than interiors. From this quiet insight emerged a broader idea. If information about a three-dimensional region can be stored on a two-dimensional boundary, then maybe this is not unique to black holes. Maybe it reflects a deeper principle about how reality itself is organized. This suggestion is known as the holographic principle. The word holographic is borrowed from a familiar object. A hologram is a flat surface that encodes a three-dimensional image. When light interacts with it in the right way, depth appears. The image feels solid and spatial, even though all the information is stored on a thin sheet. The principle does not claim that the universe is literally a hologram in the everyday sense. There is no hidden projector, no illusion meant to deceive. Instead, it suggests that the deepest description of a region of space may live on its boundary, while the interior emerges from that description. This is a subtle but profound shift. It suggests that what we experience as depth may arise from relationships encoded on surfaces we do not directly perceive. A helpful way to think about this is through shadows. A shadow on a wall can convey rich information about a three-dimensional object. Movement, shape, and even texture can be inferred from patterns of light and dark. The shadow is not the object, but it carries enough structure to recreate aspects of it. In a similar way, the universe we experience may be like a shadow, cast by deeper informational patterns living on cosmic boundaries. Importantly, this idea does not deny the reality of the world you live in. Chairs remain solid, distances remain meaningful, space still feels wide and deep. The holographic perspective simply suggests that these experiences may arise from a more economical underlying description, one that stores information in a surprisingly efficient way. This efficiency matters. It hints that the universe is not wasteful. It does not require infinite detail at every point. Instead, it may be built from a limited amount of information arranged with exquisite care. As calming as this idea may sound, it also introduces humility. It reminds us that the structures we find intuitive may not be fundamental. Volume, depth, and extension may be emergent features, not basic ingredients. At the same time, this view aligns beautifully with the layered picture we have been building. Everyday reality feels three-dimensional because that is the level at which our senses operate. Deeper descriptions may use different dimensions altogether, not as places to travel, but as ways of organizing information. As you rest with this thought, notice how it changes the feeling of space around you. The room does not shrink or flatten. Instead, it feels quietly supported, as if its solidity arises from something deeper and more subtle than surfaces alone. The holographic idea does not ask you to imagine strange worlds or hidden machinery. It asks only that you consider the possibility that what feels fundamental may not be. That depth itself may be an emergent feature, woven from patterns that live on boundaries beyond everyday awareness. With this gentle realization, we're ready to explore how such boundary-based descriptions can still reproduce the rich, three-dimensional physics we observe, and how ideas about hidden dimensions and cosmic surfaces may help bridge the gap between intuition and the deeper structure of reality. As the idea of information living on surfaces quietly settles, it begins to change how we imagine space itself. What once felt like an endless three-dimensional container now starts to feel more like a story being told from a simpler script. The richness remains, but its source may be more economical than intuition suggests. To explore this calmly, it helps to return to something familiar. Think of a holographic image on a card or a sticker. When you tilt it slightly, a three-dimensional figure seems to float in front of you. Depth appears where none physically exists. The surface is flat, yet your perception insists on volume. What makes this possible is not trickery, but information. The surface contains a carefully arranged pattern. When light interacts with that pattern, your brain reconstructs depth. Nothing is hidden behind the surface. Everything needed to create the experience is already there. The holographic principle suggests that something similar may be happening on a cosmic scale. The universe may feel deep and spacious, yet the information required to describe it may be stored on boundaries, rather than filling every point within. This idea does not require imagining that the universe is fake or projected like a movie. Instead, it invites a change in perspective. What we call space may be less like a container and more like a relationship between informational patterns. A helpful analogy is music stored on a record. The grooves on the surface look simple and flat, yet when played they unfold into a rich soundscape with rhythm, harmony and emotion. The depth of the experience does not require depth in the storage medium. In the same way, a universe described by information on a boundary could still produce galaxies, stars, planets, and conscious observers. Depth would be something that emerges during the playback of reality, not something that must exist at the most fundamental level. One of the most remarkable aspects of this idea is that it is not just philosophical. In certain simplified models of the universe, scientists have found precise mathematical correspondences between a theory defined on a surface and a theory describing a world with gravity and space inside it. In these models, everything that happens in the interior can be translated into patterns on the boundary, and vice versa. This does not mean our universe is exactly one of these models. The conditions are different, and many details remain unresolved. But the mere existence of such correspondences shows that the idea is not empty speculation. It is a concrete possibility supported by careful reasoning. What makes this especially calming to reflect upon is that nothing is lost in the translation. The interior world is not reduced or flattened. Its complexity is preserved, just encoded differently. This helps resolve a common misunderstanding. When people hear holographic, they may imagine something thin, insubstantial, or unreal. But holography in this context is about efficiency, not fragility. It suggests that reality uses its information wisely. Another way to picture this is through shadows cast by a complex object. A single shadow can reveal shape, movement, and structure. Multiple shadows from different angles can reveal even more. None of them are the object itself, yet together they carry enough information to reconstruct it. Our three-dimensional experience may be like one of those reconstructions, faithful, detailed, and meaningful, even if it is not the deepest layer of description. This perspective also helps explain why gravity feels different from other forces. Gravity is tied directly to the shape of space and time themselves. If space is emergent rather than fundamental, then gravity may be a signpost pointing toward that deeper description. It may be less like a force acting within space and more like a consequence of how information is organized. These ideas can sound abstract, but their emotional impact is surprisingly gentle. They do not shrink the universe. If anything, they make it feel more intimate. They suggest that the vastness we perceive arises from subtle relationships rather than brute expansion. As you sit with this thought, imagine the room around you not as an empty container filled with objects, but as a pattern of relationships, distances, angles, connections, quietly held together by underlying rules. The feeling of space remains, but its meaning shifts. Importantly, the holographic principle does not claim to replace everyday reality. It does not ask you to distrust your senses. It simply reminds us that what feels fundamental may be layered upon something even more fundamental still. This layered view allows us to appreciate reality at multiple levels at once. The surface level is where life unfolds, where experience has texture and emotion. The deeper level is where patterns reside, shaping what can and cannot occur. Neither level cancels the other. They are complementary, like melody and harmony in a piece of music. As our exploration continues, this idea naturally leads to questions about dimensions beyond the ones we perceive. If space itself may be emergent, then additional dimensions may exist not as places to visit, but as aspects of a deeper informational structure. These possibilities invite curiosity rather than fear. They encourage us to see the universe not as something collapsing into illusion, but as something opening into depth. With that calm curiosity, we can gently turn our attention toward ideas that imagine our universe as one layer among many, quietly embedded within a larger structure that may hold more dimensions than our senses can ever reveal directly. As the thought of holographic boundaries slowly settles, it naturally leads to another quiet question. If the space we experience might emerge from deeper patterns, then how many layers could reality have? And could our entire universe be just one layer among others? This is where ideas about hidden dimensions and so-called brain worlds begin to appear. The word itself may sound unfamiliar, but the idea behind it can be approached very gently. To begin, imagine a simple scene. Picture a long, narrow road at night. From a distance, it looks like a single line. Cars move forward and backward along it, and that seems to be the only direction available. But as you approach, you notice something else. The road has width. Cars can change lanes. What once looked like one dimension now reveals two. Now imagine standing even closer, noticing that the road has thickness, texture, and layers beneath the asphalt. What once appeared simple now contains hidden depth. In physics, something similar may be happening with space itself. The world we experience has three directions we can move through: forward and backward, left and right, up and down. Time adds another direction, carrying us gently from moment to moment. But this may not be the whole picture. The brain world idea suggests that our universe could be like a vast three-dimensional surface, a kind of cosmic sheet, floating within a space that has more dimensions than we can directly perceive. Everything we see, touch, and experience would be confined to this surface, much like ink trapped on a page. This does not mean we're surrounded by hidden corridors or secret passageways. The extra dimensions, if they exist, may be inaccessible not because they are locked, but because the rules of reality keep us bound to our layer. A helpful image is that of a soap bubble drifting through the air. To an ant walking along its surface, the bubble feels like a complete world. It can move forward, sideways, and around curves, never suspecting the vast space surrounding it. The ant's universe is the surface. The surrounding air exists, but it does not belong to the ant's experience. In this picture, our universe would be the surface. The higher dimensional space around it would exist quietly beyond perception. One reason scientists consider this idea seriously is gravity. Compared to other interactions in nature, gravity feels strangely weak. A small magnet can lift a paperclip against the pull of the entire planet. This imbalance has long puzzled physicists. the brain world idea offers a gentle explanation. Gravity may not be weak because it lacks strength, but because it is not fully confined to our layer. It may leak subtly into the surrounding dimensions, spreading itself thin. What we feel would be only a faint trace of its full presence. Again, this is not something we experience directly. It is more like noticing that a sound grows quieter as it passes through walls into another room. The sound itself has not disappeared. It has simply spread beyond where we are listening. Importantly, these ideas are not fantasy. They are attempts to reconcile different parts of physics that do not yet fit together smoothly. They arise from mathematical consistency and careful reasoning, not from imagination alone. At the same time, they remain speculative. No direct evidence has confirmed the existence of extra dimensions. Experiments have searched for subtle signs, tiny deviations in how gravity behaves at very small distances, or unusual patterns in high-energy particle collisions. But so far, reality has remained quiet. This silence is not failure, it is information. Each null result helps narrow the range of possibilities, gently guiding theory back toward what nature actually allows. What makes brain world ideas particularly calming is that they do not disrupt everyday life in any way. The presence of extra dimensions would not cause objects to vanish or people to slip between worlds. Reality remains stable because the rules governing our layer remain intact. The idea simply adds depth to our understanding, much like learning that the Earth is one planet among many does not make your home feel less real. It places the familiar within a larger context. There is also a poetic side to this view. It suggests that the universe we know is not isolated. It may be part of a grander structure, quietly coexisting with other layers that follow different rules. These layers might never interact with ours in any noticeable way, yet their existence would enrich the story of reality. As with previous ideas, it is important not to rush toward conclusions. Brain worlds are not proven facts. They are careful possibilities. They remind us that space itself may be more flexible and layered than everyday intuition suggests. They also reinforce a theme that has been quietly unfolding throughout our exploration. Reality may not be a single solid block. It may be more like a stack of transparent sheets, each revealing a different aspect of the whole depending on how closely we look. From the comfort of everyday experience to the abstract patterns of mathematics, to the idea of information living on surfaces, and now to the possibility of hidden dimensions, each layer adds depth without taking anything away. As you rest with this image, imagine reality not as something fragile or illusory, but as something spacious, wide enough to hold many structures at once. What we experience is one layer, beautifully coherent and sufficient for living. What lies beyond remains quiet, not demanding belief, only patience. With this sense of layered space gently in mind, we are ready to explore an idea that pushes unity even further, one that suggests the universe may be woven together not just across space, but across time itself, in ways that challenge how we think about individuality and separation. There is a certain kind of idea that does not ask to be believed. It asks only to be listened to, the way one listens to a story told late at night. You do not check it for accuracy line by line. You let it unfold, noticing what it makes you feel and how it quietly rearranges familiar thoughts. The one-electron hypothesis is one of those ideas. At its surface, it sounds almost playful. It suggests that all electrons in the universe might, in some deep sense, be the same electron, moving through time along a long looping path, what we perceive as countless identical particles scattered throughout space could be different moments of a single journey. seen from different angles. This is not a claim about how the universe definitely works. It is a thought experiment, a way of stretching the imagination so that time and identity begin to feel less rigid than they usually do. To understand why such an idea even makes sense to consider, we need to gently shift how we picture objects in time. In everyday life, we imagine things as existing now. A cup is on the table, a lamp is in the corner. You are here, listening. Time feels like a thin slice that moves steadily forward, carrying everything with it. Objects appear as points that persist from one moment to the next. But physics invites a different picture. Instead of imagining an object as a point moving through time, we can imagine it as a path that already stretches across time. This path is sometimes called a world line, though you can think of it simply as a thread woven through the fabric of moments. From this perspective, an object is not something that exists only now. It is something that exists across time all at once, like a line drawn through a flipbook. Each page shows a still image, but the line itself contains the entire story. If you were able to step outside time and look at the whole picture, you would not see objects popping into existence and disappearing. You would see long, continuous strands, histories laid out from beginning to end. The one electron idea takes this picture and follows it to an extreme but elegant conclusion. If all electrons are truly identical in every measurable way, perhaps that is because they are not many things, but one thing seen many times along its path. To make this feel more intuitive, imagine watching a single lantern carried through a dark field at night. If the lantern moves quickly and changes direction, and if you only see brief glimpses of it through narrow windows, you might think you're seeing many identical lanterns scattered across the field. Only later would you realize it was one light, tracing a complex route. In this story, time itself becomes the field through which the lantern moves. There is a poetic symmetry here. When electrons appear to move backward in time under certain descriptions, they can be reinterpreted as something else entirely, without changing the observable outcome. The details of that reinterpretation are technical, but the feeling it leaves behind is simple. Time may not be as one way or as intuitive as it feels from the inside. Of course, there are strong reasons not to take this idea literally. Our universe shows clear differences between matter and its mirror counterparts. The numbers do not balance in the way this simple picture would require. For that reason, the one electron hypothesis is not accepted as a physical theory, and that is perfectly fine. Its value lies elsewhere. It serves as a reminder that individuality, multiplicity, and separation may depend on how we slice reality. What appears as many things from one perspective may be one thing from another. The difference is not necessarily in the universe itself, but in the angle from which we view it. This idea resonates deeply with the themes we have been exploring. If reality is layered, if time is more like a dimension than a flowing river, then our everyday way of counting objects may be more about perception than about essence. There's also something calming about this picture. It suggests continuity beneath apparent fragmentation. A quiet unity beneath the surface complexity of the world. You do not need to imagine all electrons as literally the same traveller to feel this calm. It is enough to sense that the universe may reuse patterns, echo structures, and repeat forms across scales. The same shape appearing again and again does not always imply repetition. Sometimes it implies coherence. Think of waves on the ocean. Each wave looks separate, yet they all arise from the same water, shaped by the same forces. Their individuality is real at the surface, but their origin is shared. In a similar way, the one electron story invites us to imagine that what feels separate in space may be deeply connected through time. That identity may stretch rather than divide. As you sit with this image, notice how gently it shifts the feeling of existence. You do not become smaller or less important. If anything, you become part of a longer story, one that extends beyond the present moment, woven into the structure of time itself. This is not a conclusion. It is a pause, a place where thought softens into contemplation, and from this place it becomes easier to approach the next idea, the suggestion that even the present moment you're experiencing now may not be as singular or fundamental as it feels, that now itself could be a slice through something much larger, much calmer, and far more complete than any one instant can reveal. For now, let the image of a single thread moving quietly through time rest in your mind, not as a claim, not as a belief, but as a gentle story, one that reminds us how flexible reality can become when we allow ourselves to see it from a different angle. There is a quiet assumption most of us carry without noticing. It is the idea that the present moment is special, that it is the only moment that truly exists. The past feels gone, the future feels unreal, and now feels like a thin, glowing line where reality happens. This feeling is so natural that it rarely gets questioned. You wake up now, you breathe now, you listen now. Everything seems to arrive briefly and then slip away. But when we slow down and listen more closely, that certainty begins to soften. Imagine watching a movie late at night, when the room is dark and the world outside has gone quiet. On the screen, images move smoothly. A character walks across a room. A scene unfolds. It feels continuous, alive. Yet if you were to pause the film, you would find a single still frame. One image, frozen in time. That frame is not the movie, and yet without it, the movie could not exist. Your experience of the present may be similar. What feels like a flowing now may actually be a sequence of still moments, stitched together so smoothly that the seams disappear. The motion you feel may not belong to time itself, but to how your mind processes change. This idea can feel strange at first, but it does not require deep physics to appreciate. Even in daily life, your sense of now is not razor thin. It has width. Sounds linger for a fraction of a second. Visual impressions overlap. Memories of what just happened blend into what is happening. The present, it turns out, is already a small stretch, not a perfect point. From a deeper perspective, time may not be a river that flows. It may be more like a landscape. Past and future may exist in the same way that distant places exist. You are simply located at one position within it. This is difficult to feel intuitively because your awareness moves. You experience moments in sequence, not all at once. But that does not mean the sequence itself is being created as you go. It may already be laid out, like a long road you're walking along. To make this gentler, imagine reading a book. All the pages exist at the same time. The beginning, the middle, and the end are all there, quietly bound together. Your experience of the story unfolds page by page, but the story itself does not come into existence only when you read it. Time may be similar. Your consciousness turns the pages. Reality holds the book. This does not mean the future is fixed in a way that makes choice meaningless. It simply suggests that fixity and flow may belong to different levels of description. From inside the story, choices feel open, uncertain, and alive. From outside the story, the structure may appear complete. Both perspectives can be true without contradicting each other. What matters for our quiet exploration is the emotional shift this brings. If the present moment is not the only real moment, then the past is not vanished into nothingness. It still exists as part of the structure, and the future is not empty. It is simply not yet experienced. This can be oddly comforting. Moments you cherish are not erased. They are woven into the fabric of time. Moments you worry about have not rushed toward you. They wait calmly, like unopened pages. The sense of urgency we often feel may come not from time itself, but from how we move through it. Your brain is designed to highlight change. It draws attention to what is new, what is shifting, what demands response. In doing so, it creates the impression of a constantly vanishing present. But this may be more about perception than about reality. There's a subtle peace in considering that nothing is truly rushing past you. You're moving through a structure that remains whole, even as you experience it one moment at a time. This idea also connects quietly with the sense of unity we touched on earlier. If time is a dimension rather than a flow, then separation between moments is not absolute. The past is not disconnected from the present. The future is not isolated from the now. They're all part of the same shape. You do not need to visualize this shape precisely. It is enough to sense it. The way you sense the shape of a room in the dark without seeing every corner. The feeling matters more than the detail. As you sit with this thought, notice how it changes your breathing. There is no need to hurry, no need to grasp the present tightly before it disappears. It was never going anywhere. This does not make the present less meaningful. In fact, it can make it more gentle. If the present is a window rather than a cliff edge, you can look through it without fear of falling. You're here because this is where your awareness is focused, not because other moments are unreal. And as awareness continues its quiet movement, it will encounter ideas that suggest even space and time themselves may not be solid foundations, but behaviors of something deeper and more fluid. For now, let the idea of the present as a soft slice rest in your mind, not as a conclusion, but as a feeling, a sense that time is wide enough to hold everything, even as you experience it slowly, one breath, one thought, one gentle moment at a time. As the idea of time as a wide, quiet structure begins to settle, it becomes natural to wonder about the stage on which time unfolds. We often imagine space as emptiness, an invisible container holding stars, planets, and ourselves. It feels passive, silent, and unchanging. But modern thought invites a softer, more fluid picture. What if space and time together behave less like a rigid framework and more like a kind of medium? To approach this idea, imagine standing by a lake early in the morning. From a distance, the surface looks perfectly calm. It reflects the sky so clearly that the boundary between water and air almost disappears. At that scale, the lake feels smooth and continuous. Now imagine dipping your hand into the water. You feel motion, resistance, subtle currents. Look even closer, and you would find countless tiny movements, molecules sliding past one another, forming patterns too small to see directly. The calm surface was never truly still. It only appeared that way from far away. Some scientists use a similar image to think about space and time. At large scales, where planets move, clocks tick, and galaxies drift, space and time feel smooth and predictable. They curve gently, stretch subtly, and behave in ways we can describe with remarkable accuracy. But at extremely small scales, that smoothness may break down. Space and time may have texture. They may ripple, swirl, or form tiny structures that average out when viewed from afar, much like the motion of water molecules disappears when you look at the lake as a whole. This is where the idea of space-time as a kind of superfluid enters the story. A superfluid is a state of matter that flows without friction, moving smoothly and continuously under the right conditions. While the details belong to laboratories and equations, the feeling of the idea is simple. It suggests effortless flow, coherence, and hidden order. In this picture, space-time itself would not be an empty backdrop. It would be an active participant, capable of motion and vibration. What we perceive as gravity, the gentle attraction between masses, could be a large-scale effect of this flowing medium responding to the presence of matter and energy. To make this feel intuitive, imagine placing a small pebble into a still pond. Ripples spread outward, not because the water is being pushed by an invisible force, but because the surface itself responds to disturbance. The motion belongs to the medium. Similarly, massive objects might create subtle disturbances in the fabric of space-time, sending out faint ripples that travel across the cosmos. These ripples are extraordinarily gentle, far beyond direct human perception, yet sensitive instruments have learned how to listen for them. What matters for our quiet exploration is not the measurement, but the implication. Space and time may not be passive. They may behave more like a living surface, capable of motion, tension, and release. This idea offers a graceful bridge between two very different ways of understanding reality. On one hand, we have the smooth, geometric picture of space-time that works beautifully at large scales. On the other, we have the restless, fluctuating picture of nature at tiny scales. Thinking of space-time as a fluid allows both pictures to coexist. From far away, the flow looks calm and continuous. Up close, it may be restless and structured. Importantly, this is not a claim that space is literally made of liquid, or that you could scoop it up with a cup. It is an analogy, a way of borrowing intuition from something familiar to approach something abstract. Analogies are powerful not because they are exact, but because they guide feeling. They allow the mind to rest while still exploring. There is also something deeply calming about this picture. A fluid universe is not brittle. It bends, adapts, and flows around obstacles. It absorbs disturbances rather than shattering. This aligns beautifully with the sense that reality, despite its complexity, remains stable and resilient. When stars collide or massive events unfold, space-time responds smoothly, carrying information outward like gentle waves on water. The universe does not tear or break, it flows. This fluid picture also fits naturally with the idea of emergence we will soon explore more fully. In fluids, large-scale behavior arises from countless tiny interactions. Temperature, pressure, and waves are not fundamental particles. They are collective phenomena. If space-time behaves similarly, then the smooth world we experience may emerge from deeper, finer structure without needing to be fundamental itself. This does not make space-time unreal. It makes it relational. Its properties arise from how its underlying elements move together, not from isolated components. As you sit with this image, notice how it changes your sense of place. The room around you does not feel rigid or mechanical. It feels gently supported, as if held within a larger flowing whole. Nothing is straining, nothing is about to collapse. Even time, which so often feels urgent, becomes softer here. If space-time flows, then time may be carried along like a leaf on water, moving steadily, without effort, guided by the shape of the current. This perspective does not answer every question. It does not claim to be the final word on the nature of reality, but it offers something valuable, a sense of continuity between the calm world of experience and the restless depths beneath it. It reassures us that complexity does not imply chaos. That motion does not imply instability, and that depth does not imply danger. As the idea of a flowing space-time gently settles, it prepares the ground for an even quieter realization. Perhaps the word illusion does not mean what we often think it means. Perhaps it does not refer to deception at all, but to emergence, the way rich experiences arise naturally from deeper layers without losing their reality. For now, let the image of a calm lake with hidden currents remain in your mind, a universe that flows, responds, and holds together, not as a rigid machine, but as a graceful medium in which all things gently unfold. By now, the word illusion may feel different from how it did at the beginning of our journey. Early on, it might have sounded like a challenge to reality itself, as if the world were somehow pretending to be something it is not. But after travelling through ideas of layers, patterns, time, and flowing spacetime, a softer meaning begins to emerge. An illusion does not always mean deception. Often, it simply means emergence. To see this clearly, consider a rainbow. When you see one arcing across the sky, it feels vivid and unmistakably real. You can point to it, photograph it, admire its colours, and yet if you try to approach it, it recedes. It does not exist as a physical object you can touch or collect. The rainbow is not a trick. It is not pretending. It emerges naturally when sunlight, water droplets, and your position in space align in just the right way. Change any part of that relationship and the rainbow fades. But while it is there, it is fully real as an experience. The same is true of a wave on the ocean. A wave travels across the surface, rising and falling with grace. You can surf it, hear it crash, feel its force. Yet no single molecule of water journeys from the beginning of the wave to the end. The wave is a pattern, not a thing. Its reality lies in motion and relationship, not in substance. Temperature offers another gentle example. Warmth feels immediate and undeniable. You know when a cup of tea is hot. But warmth is not a particle you can point to. It emerges from the collective motion of countless tiny components, moving together in a particular way. The experience is real, even if the underlying description is abstract. In each of these cases, something meaningful arises from deeper processes without being a fundamental building block. The rainbow is real without being an object. The wave is real without being a traveller. Warmth is real without being a substance. Reality itself may be similar. What we experience as solid objects, flowing time, and continuous space may emerge from deeper layers of organisation. Those layers may look nothing like tables, clocks, or rooms. They may consist of relationships, patterns, and interactions that only resemble the world we know when viewed from the right scale. This does not make everyday reality less important. On the contrary, emergence gives it strength. Emergent phenomena are often more stable and meaningful than their underlying parts. A melody is not found in any single note. It exists only when notes come together in a particular order. Yet the melody can move us more deeply than any isolated sound. If reality is emergent, then calling it an illusion misses the point. It is not hiding truth. It is expressing it in a form suitable for experience. This perspective also dissolves a common fear. People sometimes worry that if reality is not fundamental, then it is somehow fragile or untrustworthy. But emergent things are not weak. They are robust. They persist precisely because they arise from many components acting together. A traffic pattern exists even though no single car creates it. A language exists even though no single speaker defines it. A society exists even though no single person contains it. These realities are not illusions, they are collective truths. In the same way, the world you experience may be a collective expression of deeper processes. It is no less real because it is not fundamental. It is real because it works, because it holds together, because it supports life and awareness. This reframing brings a sense of ease. You do not need to choose between believing the world is real or believing it is an illusion. Those categories belong to a simpler way of thinking. Reality can be both emergent and meaningful at the same time. It also brings humility. If what we experience arises from deeper layers, then our everyday perspective is not the final word. There may always be more beneath the surface, more connections waiting to be understood. But this is not a threat. It is an invitation to curiosity. As you rest with this idea, notice how it softens earlier questions. Whether the universe is simulated, mathematical, holographic, or fluid becomes less urgent. These are different ways of pointing toward depth. None of them erase the reality of experience. They simply suggest that experience has roots. Those roots may lie in information, in structure, in motion, or in relationships we're only beginning to glimpse. The surface world, the one you live in, remains the place where meaning unfolds. This understanding also prepares us for the final turn of our journey. After exploring so many possibilities, it becomes important to ask how we actually test them. How do we distinguish between what can be measured and what must remain philosophical? Where does careful science draw its boundaries? Recognizing emergence helps here too. Science does not demand ultimate answers. It builds models that work at particular levels. It tests them, refines them, and sometimes sets them aside. It does not seek to strip reality of meaning. It seeks to understand how meaning arises. As the word illusion continues to dissolve into something gentler, we can allow ourselves to appreciate the world without suspicion. The floor beneath you does not vanish because it is emergent. The passage of time does not lose significance because it may be a slice through a larger whole. Emergence does not subtract, it adds layers. For now, let the image of the rainbow remain with you. A beautiful arc that appears when conditions are right, real without being permanent, meaningful without being fundamental. Reality may be much the same, an ever-present pattern arising from deeper order, quietly trustworthy and endlessly rich. After travelling through ideas that stretch imagination, layers of reality, flowing space-time, emergence, it becomes important to rest our feet on solid ground, not to undo what we've explored, but to see how careful science engages with these questions in its own calm, patient way. This is where experiments enter the story. CERN is often spoken about in dramatic tones, as if it were a place where reality might crack open, or hidden worlds might suddenly appear. In truth, its role is far quieter and far more reassuring. It is not a place where scientists try to break the universe. It is a place where they listen to it very carefully. At CERN, particles are guided along long circular paths and gently encouraged to meet. These encounters are not violent acts of destruction. They are conversations, brief exchanges of energy that reveal how nature behaves when examined closely. The goal is not to summon new realities, but to test ideas that already exist. Ideas about how matter is structured, how forces behave, and where the boundaries of current understanding truly lie. One of the most important things to understand about experiments is that they do not exist to confirm our hopes. They exist to challenge them. An experiment is successful not when it proves a favourite idea, but when it tells us something honest, whether that something is yes, no, or not this way. In this sense, science advances as much through absence as through presence. When scientists look for signs of extra dimensions, for example, they are not expecting to see doors open in space. They are looking for subtle fingerprints, tiny changes in how energy is distributed, or small deviations from expected patterns. If those fingerprints are not found, the idea does not collapse into failure. It simply becomes more constrained. The universe has quietly said, if this idea is true, it must live somewhere else. The same is true for many bold ideas we've encountered. Holography, hidden dimensions, new forms of matter, all are guided by mathematical consistency and imagination. Experiments then step in to ask which versions of these ideas can actually exist in our universe. This filtering process is slow, deliberate, and deeply respectful of reality. It treats nature not as something to be conquered, but as something to be consulted. One of the most famous outcomes of this approach was the discovery of a long-predicted particle that helps explain why some things have weight. Its appearance did not rewrite reality overnight. Instead, it confirmed a piece of a puzzle that had been quietly forming for decades. The excitement came not from surprise, but from alignment, the feeling that observation and theory had finally met. Equally important are the ideas that have not yet found support. Entire families of possibilities have been narrowed or set aside because experiments did not see what those ideas predicted. This is not disappointment, it is progress. Imagine walking through a dark room with a flashlight. Each sweep of the beam does not illuminate everything at once. It reveals what is there and, just as importantly, what is not. The darkness does not mean ignorance. It means the light is being used carefully. Science works the same way. Each experiment narrows the darkness, shaping our understanding by removing what cannot be. This perspective helps dissolve a common misunderstanding. Science does not promise ultimate answers. It promises careful refinement. It builds models that work within known limits and remains open to revising them when new evidence appears. That humility is its strength. When dramatic myths arise, claims of hidden portals, catastrophic experiments, or secret dimensions being torn open, they misunderstand this process. Such events would leave unmistakable signatures, not subtle hints. The absence of those signatures is not suspicious, it is reassuring. The universe is remarkably consistent. It does not behave wildly when examined closely. It responds with the same calm reliability it shows in everyday life. This consistency is part of what makes our earlier explorations meaningful rather than frightening. Layers of reality do not imply instability. Emergence does not imply collapse. Depth does not imply danger. Experiments remind us that even the strangest ideas must answer to observation. And observation, again and again, shows a universe that is patient, structured, and remarkably well behaved. There is also something quietly poetic about this process. Humans build intricate machines to ask simple questions, and the universe answers without words. Sometimes the answer is a signal, sometimes it is silence. Both are forms of communication. Silence tells us where not to look. It saves us from chasing endless possibilities. It guides attention toward paths that remain open. As you sit with this thought, notice how it reframes uncertainty. Not knowing everything is not a failure. It is a natural state when exploring something as vast as reality itself. What matters is how we respond to that uncertainty, with care, patience, and curiosity rather than fear. CERN and places like it do not stand in opposition to wonder, they support it. They ensure that wonder remains grounded, that imagination stays connected to what can be tested, and that stories about reality remain honest. This grounding prepares us for the final steps of our journey. With science gently narrowing the field, it becomes possible to separate thoughtful possibilities from dramatic myths, and to see how reality remains stable even as our understanding deepens. From here, we can turn calmly toward the stories people tell when imagination outruns evidence, and see how careful science responds, not by dismissing curiosity, but by bringing it back into balance. Whenever ideas about deep reality reach a wide audience, stories begin to grow around them. Some are poetic, some are playful, and some drift toward fear. It is natural. When imagination moves faster than evidence, the unknown can feel threatening. Over the years, powerful images have taken root in popular culture. Portals opening in space, hidden dimensions tearing through reality, experiments that might accidentally unravel the universe. These stories are vivid, cinematic, and emotionally charged. They are also very far from how science actually works. To understand why, it helps to return to a simple principle. Nature speaks quietly. When something profound happens in the universe, it does not announce itself with spectacle. It leaves traces, small, consistent signals that can be measured, repeated, and checked by many observers. Science listens for these traces patiently, without expectation of drama. The idea of a portal, for example, often appears in fiction as a glowing doorway connecting distant worlds. In reality, if there were any new pathways in space, they would not behave like doors. They would reveal themselves indirectly, through tiny changes in how particles move or how energy spreads. No sudden openings, no flashes of light, just subtle differences that repeat under careful conditions. This distinction matters. Fiction is designed to engage emotion quickly. Science is designed to remove ambiguity slowly. Another common fear involves catastrophic accidents. The worry that experiments might create something dangerous, something uncontrollable. This concern often arises from misunderstanding scale. The energies involved in laboratory experiments, while impressive by human standards, are tiny compared to what nature produces routinely. The universe has been conducting far more extreme experiments for billions of years. High-energy events occur naturally in cosmic environments, far beyond anything humans can replicate. And yet, the fabric of reality remains intact. If certain catastrophic outcomes were possible, they would have already happened naturally long before any human-built instrument existed. The continued stability of the universe is itself a quiet piece of evidence. Science does not proceed by ignoring risk, it proceeds by understanding it. Before any experiment is performed, scenarios are analysed, limits are calculated, and comparisons are made with natural processes. This careful groundwork is not dramatic, but it is essential. Transparency is another important element. Scientific results are shared openly, methods are published. Independent teams verify findings. This openness acts as a safeguard, ensuring that no single group controls interpretation or hides outcomes. When myths persist, they often do so because uncertainty feels uncomfortable. A mysterious danger can seem more compelling than a measured explanation. But comfort does not come from exaggeration. It comes from understanding. One helpful way to think about this is to compare scientific instruments to microscopes. A microscope does not create bacteria. It reveals them. It does not alter reality. It sharpens our view of what is already there. In the same way, powerful experiments do not open new realms. They illuminate existing structure. This perspective gently reframes the relationship between curiosity and caution. Curiosity drives us to look deeper. Caution ensures that looking deeper does not turn into projection of fear. It is also important to remember that science thrives on limits. Discovering what does not happen is just as informative as discovering what does. When predicted phenomena fail to appear, the range of viable theories narrows. The landscape of possibilities becomes clearer. This is not disappointment, it is progress. The myths often imagine science as trying to force the universe into revealing secrets. In reality, science is more like a conversation. A question is asked. Nature responds. The response is accepted, even if it contradicts expectations. This humility is one of science's greatest strengths. It prevents runaway speculation. It keeps imagination tethered to observation. As we consider all the bold ideas we have explored, layers of reality, hidden dimensions, emergent spacetime, it becomes clear that none of them imply danger by default. They are attempts to describe structure, not to disrupt it. Reality has proven to be remarkably robust. It absorbs inquiry without breaking. It accommodates curiosity without collapsing. The deeper we look, the more consistency we find. This consistency is deeply calming. It suggests that the universe is not a fragile illusion waiting to shatter. It is a stable process, unfolding according to rules that hold across vast scales of time and space. When fear-based myths fade, what remains is something quieter and more meaningful. A sense of trust. Not blind trust, but trust built on repetition, evidence and care. You do not need to fear the unknown to respect it. You do not need catastrophe to feel wonder. As you rest with this understanding, notice how the emotional tone of reality changes. The unknown becomes spacious rather than threatening. Questions become invitations rather than warnings. This gentle clearing of fear prepares us for the final reflection. Once myths are set aside and science is spoken in its calm voice, we are left with a deeper question, not about danger or deception, but about perspective. If reality can be layered, emergent, and deeper than appearances suggest, then how should we think about truth itself? Is reality something that must be either fully real or fully illusory? Or is it something that becomes richer as we explore its depth? With this calm curiosity, we are ready to step into our final reflection, one that does not seek to resolve the mystery, but to rest comfortably within it. After exploring so many ideas, interfaces and layers, flowing spacetime, emergence, careful experiments, it becomes natural to want a final answer, a clear conclusion, a simple statement that says, at last, whether reality is real or an illusion. But perhaps that desire itself comes from an older habit of thinking. We're used to sharp categories, true or false, solid or imaginary, real or fake. These distinctions are useful in daily life. They help us navigate quickly and make decisions, but as we've seen, they can become too rigid when applied to something as vast and subtle as reality itself. What if reality does not fit comfortably into those boxes? Throughout this journey, a quieter pattern has been forming. Again and again, the universe has shown itself to be layered. What appears solid emerges from something deeper. What feels fundamental turns out to rest on structure, relationship, or pattern. And what first sounds like illusion often reveals itself as emergence, something real arising naturally from deeper order. In this light, the question, is reality an illusion, begins to feel slightly misaligned. It assumes that if something is not fundamental, it must be false, but that assumption no longer holds. A rainbow is not fundamental, yet it is real. A wave is not an object, yet it is real. Music is not a physical substance, yet it is real. Each exists because conditions align, patterns form, and relationships hold. Reality may be much the same. The world you experience, the room around you, the passage of time, the sense of being here now, does not need to be the deepest layer to be meaningful. It only needs to be coherent, stable, and shared, and it is all of those things. Perhaps the more helpful question is not whether reality is real or illusory, but how deep it goes. Depth changes perspective. When you look at the ocean from the shore, you see waves. From above, you see currents. From deeper still, you would find temperature gradients and slow-moving layers. None of these views cancel the others, they complete them. Reality may invite the same kind of viewing. At one level, it is the world of everyday life, full of sensation, memory, and meaning. At another level, it is a network of relationships, patterns, and flows that do not resemble everyday objects at all. Both levels are real in their own way. Science, at its best, helps us move between these levels without forcing a single story. It shows us how descriptions change with scale, how explanations adapt to context, how certainty gives way to approximation, and approximation gives way to deeper questions. Importantly, science also shows us where its reach ends. There are questions it can refine but not fully settle. Questions about why these structures exist rather than others. Questions about why experience arises at all. These are not failures. They are boundaries, edges where curiosity can rest without rushing forward. There is something deeply human in that restraint. As listeners, as thinkers, as quiet observers of the universe, we do not need final answers to find peace. We need a sense that reality is stable enough to trust and deep enough to explore. The journey itself becomes the point. In this way, reality begins to feel less like a puzzle to be solved and more like a landscape to inhabit. You move through it. You learn its contours. You notice how different views reveal different truths. And perhaps the most calming realization of all is this: nothing we have explored requires reality to be fragile. Layers do not weaken it. Emergence does not undermine it. Depth does not threaten it. Reality holds. It holds waves and particles, time and space, stories and experiments. It holds your experience right now without demanding that you understand its foundations. You're allowed to live on the surface while deeper structures quietly do their work beneath. This does not make you distant from truth. It makes you part of it. As the question of illusion slowly dissolves, what remains is a gentler curiosity. A sense that the universe is not hiding from us, but revealing itself gradually, at a pace we can absorb. And so, instead of asking whether reality is an illusion, we might ask something softer. How many layers does reality have? How many ways can it be understood? How many perspectives can coexist without cancelling one another? These are not questions that demand immediate answers. They are questions that can be carried lightly, like smooth stones in a pocket, noticed from time to time, then allowed to rest. As you settle into this final thought, notice the quiet around you, the steady presence of the moment, the absence of urgency. Reality does not need to prove itself to you. It is already here, already supporting you, already deep enough to hold both mystery and meaning. And so, we arrive at the end of tonight's exploration. Whether your eyes are still open, or you're already drifting somewhere between waking and dreaming, thank you for sharing this gentle journey. If you'd like to wander again through quiet questions and calm discoveries, you're always welcome to return. Reality may be deeper than truth or illusion, but in this moment it is simply the soft place where you can rest. Sleep peacefully, wherever and whenever you may be.